It was as good as, I think. Yeah. Obviously as good as. Is our sample is representative. Now, for my normality of the sampling distribution, and every once in a while I like to write out sampling distribution because you know what we're finding the normality of, not of the sample distribution, of the sampling distribution, which are those things on the wall, or the front one on the wall. I have to check, again, 4 times, but I'm going to check N1 times my pooled proportion. And N1 times 1 minus my pooled proportion. And my N1, I guess I'll call that juniors. And how many juniors is that? 10? All right. So this is 10 times 0.7 is 7. And 10 times 0.3 is 3. Oh, we may not be meeting conditions. These need to these either need to be greater than or equal to 5 or 10. You can use either one. We didn't make it. Yeah, right. That's what we can budget. Oopsie. Is that how you spell oopsie? We don't have any guarantees of our sampling distribution being normal. We needed 2 classes worth of data, I'm sure. But we'll proceed with caution. That's right. Just proceed with caution. And then we have to do the same thing for the seniors. And the seniors are 17. What's 0.7 times 17? Well, yeah, it's enough.
Okay, so we met conditions. All right.
Sort of. 11.9 and what's 17 minus 5.1?
Yes, we met conditions.
Okay. Okay. Well, we're okay. we'll go ahead with this. Just as there's was a little lacking of juniors in general. That's just not enough juniors. Okay. And independence. We're going to sample from a population of juniors that's got to be greater than 10 times n. Well, a universe, not world, universe. And the population of seniors got to be greater than 10 times n seniors. 170. We're fine there. Pretty much. Okay, met one of the conditions. Okay. Now, of course, you're not going to memorize this formula, but my test statistic is, for those of you who don't like to use the calculator and just would prefer to do this on your own, I take my p-hat of my junior minus my p-hat of the seniors. That's the direction we did it, right? Yeah, I think that's right. And then I got to take my pooled proportion, and they kind of shortcut the formula a little bit in the book, but who cares? I'm gonna put a square root sign there eventually, but 1 over my sample size of my juniors plus 1 over the sample size of the seniors. Take the square root of all of that. And I am just going to, now that I've written that down, I think I'm just going to shove that data into my calculator. Anybody figure out the right button yet?
Somewhere in there.
Grab your calculator to see what button we're going to, what test we're going to.
Wait, we're doing the test?
This is a significance test, so we're not on the interval page. So is this T or Z?
Yeah.
Z, this is a normal. One proportion. It's number 6. 2 proportion Z test.
Oh, by the way, where do they get these
Where? Oh, you want to go all the way into where they get these formulas?
formulas? Maybe not.
They come right out of the stuff we did in chapter 8 with combining random variables. They're, go back and look at that, and these are the formulas that come from combining random variables, along with the binomial estimation. All right, so I got 8 and 10 and 11 and 17, and I do a greater than test. I did something wrong. Z is what?
0.84.
Why do I have 0.84? Are we doing a not equal to or a greater than? We're doing a greater than. Yeah. Yeah. All right. So my Z, I got 0.84. I got a p-value of 0.20. And if you were doing this on an exam, you would just want to go ahead and write out all the computer output. My proportion of juniors is 0.8. My sample proportion of seniors was 0.65. I can't remember if we wrote this out before. If we didn't, write it out again. Okay. So, since my p-value is greater than any reasonable 25. Oh. We fail to reject our null hypothesis.
It's obvious.
We do not have evidence there is, is a difference in the conditions of juniors and seniors books. So as you take Sun Gen out and you got significance at the level of 10%? Yeah. Yeah. Okay. All right. Move him.